Alright, example 1, consider the points A, 2, 5, 1, B with the coordinates negative 2, 6, negative 4, and C with the coordinates 4, 0, 3. Find AB, the vector AB. Alright, and also find the coordinates of D such that AB, the vector AB, is the same as the vector CD. Okay, so what would this look like? Let's see. Let's start with the first one. Find the vector AB. AB is really, we said, OB, right? The vector from where the origin, the position vector of B relative to O minus the position vector of A relative to O. Okay, and so OB is just the coordinates of the point B written in vector form, isn't it? And same thing with OA. OA is just the vector, or sorry, the coordinates of point A rewritten in component form, where we're in vector component form. So OB here was negative 2, 6, negative 4, so we just write that vertically to write OB. Point A was 2, 5, 1, so we write that vertically, 2, 5, 1, and we take the difference of those. And so we end up with negative 4, 1, minus 5. Remember, we do minus 2, 6 minus 5, and minus 4 minus 1. We just read it straight across. Okay, and there we have our vector AB. All right. Find the coordinates of D such that AB is equal to CD. So this is our condition. AB must be equal to CD here. Okay? So if we know this must be true, we can say that the vector AB, which was over here, we found that, is equal to a new vector CD. Okay, we know C, all right? And so it looks like the vector CD would be the vector OD minus OC, right? The position vector of D relative to O minus the position vector of C relative to O. So I think we can figure this one out. That's pretty easy. That's just this vertically rewritten, but we don't know this one. Okay, we don't know OD, so we create some new variables. So we say let D be the point x, y, z, right? We're using new variables to indicate the coordinates of point D, and then we're going to write this vertically. So we have CD equals OD minus OC, XYZ minus 403, and now we just perform our operation, x minus 4, y minus 0, and z minus 3. Okay? Now we can say, since we said AB must be equal to CD, we can say AB, right here, is equal to CD, which was here. I simplified my y. Now I know that they're equal vectors, so their components must be equal, right? So I say, I'm really going to have three equations here. I have this is equal to this is equal to this, and this is equal to this. So I have minus 4 equals x minus 4, which leads us to x equals 0. I have 1 is equal to y, which is nice, so that's one value right there. And I have minus 5 is equal to z minus 3. Okay? Which leads me to z equals minus 2. So there I have my variables x, y, z. We said D was this point, so D is 0, 1, minus 2. Alright, so pretty simple, but you know, this might be the tricky part here, is creating that new variable and then setting that equal to what I already know. Alright, let's look at example 2. Let A be the vector 5, minus 1, 3, and B be the vector minus 2, 2, 6. What is the magnitude of A, right? This means the magnitude of A. And what is 3A minus B? So we're just doing a little bit of vector algebra here. And find the angle between A and B. So we're probably going to be using our cosine rule, right? Not our cosine rule, but our cosine formula that has the dot product in it. So we need to know the dot product for this one. Let's go back to part A. Find the magnitude of A. That seems pretty easy. I take my coordinates, square each of them, and then add them all up, and then take the square root of them, right? So I'm going to do 5 squared plus minus 1 squared plus 3 squared. Take the square root of that, I get root 35. All right, that's going to be the magnitude of A. For part B, I say, it says find 3A minus B. So it's going to be 3 times the vector A minus the vector B. So we're just going to break this into two parts and do this part first, and then combine these two vectors. We're going to do our scalar multiplication first. So we do 3 times 5, 3 times negative 1, 3 times 3. Add that vector, or take away from those components, the components of B, and we end up getting 17, negative 5, and 3. Okay. The angle between A and B, we're going to need to use the dot product here. Okay, and we know this formula. We talked about this previously in the previous video. Okay, so I need to find the dot product of A and B all over the magnitudes of A and B multiplied together. Notice that this is not a dot product. This is a dot product because it has a big circle in it. Okay, so we take the components, the x components of these, multiply them together, the y components and the z components, multiply them together, and then we add those products together. So we do 5 times negative 2, 5 times minus 2, plus minus 1 times 2, plus 3 times 6. Okay, on top. And on the bottom, we already found the magnitude of A, so we just need to find the magnitude of B, which is the same process that we did in part A. We do 2 squared plus 2 squared plus 6. Minus 2 squared is the same as 2 squared. So we end up with 4 plus 4 plus 36, which leads us to root 44. The top simplifies to 6. And now I just get my calculator ready. Okay, since it says find, we still need to show all of our work here. Okay, and then we find theta. We use the inverse cosine of this, and we end up with 81.2 degrees is the angle between A and B.